One of the things you may have noticed the other day is that when we were simplifying square roots, we were only working with perfect squares, but there are lots of numbers that aren't perfect. So we're going to need to deal with those as well. But first, some background. Remember that we had this property with exponents, where if you had something times something else to a power, then you could apply the power to both things. Or a different example, if we had the quantity 2x and it was cubed, well, that was the same thing as 2 cubed times x cubed, which is just 8x cubed. And hopefully you remember that, because there's a similar property with square roots. And the idea with square roots is that if you have something, it's the square root of something times something else, then you can consider the square root of the first thing times the square root of the second thing. And that can come in handy with numbers like 50, like the square root of 50. And because 50 isn't a perfect square, but we can think of 50 as 2 times 25. And that's really helpful because 25 is a perfect square. Since this is the same as the square root of 2 times the square root of 25, just like the property, then this becomes the square root of 2 times 5. And typically, instead of writing it in that order, we would put the number outside of the square root first and write it as 5 times the square root of 2. And that's generally the idea of how we will go about simplifying square roots when it doesn't involve a perfect square. Let's look at another one. Let's consider the square root of 500. Well, there's lots of different ways to think about this, and you may think about it different than me, but I'm going to think about this as 5 times 100. And I'll write it this way, 100 times 5. And we know by our property that that's the same thing as the square root of 100 times the square root of 5. But the positive square root of 100 is 10. So we have 10 times the square root of 5. Why don't you try a couple? Why don't you first try the square root of 48, and then try the square root of 288. Go ahead and hit pause and give it a shot. Let's see how you did. Now for 48, to me it's not obvious how to think about this, but I'm going to start with the first perfect square, which is 4. Because 48 is 4 times 12. And 12 actually goes further. 12 is the same thing as 4 times 3. So now using my property, this is the square root of 4 times the square root of 4 times the square root of 3. And we know that the square root of 4 is 2. And when we finally finish our multiplication, we get 4 times the square root of 3. Let's look at the last one for this video. 2 and 188. Now, I can see that 288 is 2 times 144. I'm going to do this two different ways. Some of you might not have seen that. So this is the square root of 2 times the square root of 144, which is the square root of 2 times 12. And we would always write it as the number outside the square root going first, 2, or 12 times the square root of 2. Let's look at that a different way. Some of you may have thought of it this way. You might have broken it down as 4 going into 288. That would be 7 times 72. And if we focus just on perfect squares, well, 72 is 4 times 18. And this looks like a complicated way to do it, but it's really not too bad because 18 is 9 times 2. And I know the square root of 4 is 2. There's a second square root of 4. The square root of 9 is 3. And I have this 2 left over. And 2 times 2 times 3 is the square root of 2. With the point being, square is 12 times the square root of 2. And the point being, you can think about this a lot of different ways, and as long as you follow the property, it'll work out just fine.